Got a couple guys here. Their title of their talk, Meeting Your Nemesis, Fighting Data with Data. We've got Will Schroeder and Maxwell Harley. Please welcome them and enjoy the talk.
All right. How's everyone doing? Having a good con, hopefully? We're really excited to talk about Nemesis. It's a project we've been working on for close to a year now. It's been a lot of blood, sweat, and tears that have gone into it. We think it's pretty cool, but we're going to talk about, we'll cover the agenda here in a second, but kind of the TLDR with Nemesis. It's an offensive data analysis and enrichment platform. It does a whole bunch of really cool things that we're going to get into, and we'll go ahead and kick everything off.
Cool. So for the agenda today, we're going to start off with some introductions, talk about some existing red team challenges we have, currently face. We work at SpecterOps. We have a pretty, fairly large red team. So we're going to talk kind of about the challenges we have. And we're going to talk about the goals and visions for the Nemesis platform, trying to solve some of the issues we see in red teaming currently. We're going to talk about Nemesis, how it's architected. We're going to talk about data collection, and data analysis, do some demos, talk about why it matters, and then end with some questions.
And we do have some cool giveaways for questions at the end for the most interesting couple of questions that people might have. So who are we? I'm Will Schroeder. I go by Harmjoy on GitHub and Twitter or X or whatever else and all the social medias. I'm a researcher at SpecterOps. I've been with the company since the beginning. I've talked to a lot of conferences over the years. I've trained a lot of different places. I'm also a pretty avid open source developer for offensive tools specifically. So I was the co-developer of PowerShell Empire. PowerSploits I worked on for a good period of time with specifically PowerView and PowerUp. If anyone had used those, I was one of the co-founders and initial developers for the Bloodhound project. I built a lot of the tools in GhostPack, which is a collection of C# offensive-oriented tools. And one of the more recent things that I did with a workmate, Lee Christensen, whose bio is up there. He's not here today, but he is one of the other core developers on Nemesis. But he and I did the Active Directory certificate services, the certified pre-owned research from a couple years ago with all the fun ADCS pwnage type stuff.
And I'm Max Harley. My CV is not nearly as extensive as Will's, but I do consulting, offensive security consulting. Wrote some infrastructure automation, like red team infrastructure automation for SpecterOps. Do a lot of software engineering, developed a few projects, Satellite, JA3 Transport, Go Fish Notifier, and I'm a Clemson grad, so go Tigers. We're playing Wake Forest today, I think, so hopefully we win.
And for people not familiar with SpecterOps, we're a consultancy. We have a commercial tool for Bloodhound Enterprise and stuff, but we've been doing red team engagements and blue team engagements for a number of years. So we've probably done hundreds and hundreds of engagements now from both pen testing and red teaming. So a lot of the challenges that we've seen over the years in some of those engagements is really what inspired us to start building the Nemesis platform.
Yeah, so here's some of the challenges we face. The first, we have a large team. This is tradecraft, especially trying to teach new people, tradecraft that people might not be familiar with. Like tradecraft, it's hard to scale. Every operator kind of has their own skill set. We have a lot of people on the team who are really good at things like SCCM abuse, whereas other people are not as good. So how do we take that knowledge? It's a difficult problem. How do you take that knowledge and then allow or enable the other members of the other operators on your team to perform that tradecraft? When new tradecraft comes out, maybe not even things that you've researched. When new tradecraft comes out, how do you scale that? How do you teach people that information? Another problem we see is offensive data not being unified. There's a number of C2. I mean, if you look at C2 platforms that are on GitHub, the list is like 500. There's 1 million C2s out. There's a whole C2 matrix that has all the different ones. And the problem is those C2s, they silo their data. Their logs are all stored on one platform, but we want a unified view. If we're using multiple C2s or multiple tools, maybe we're proxying tooling in. We want a unified view of what that, what does our current operating platform, what does our environment look like? We don't have one singular view for that.
For example, on most engagements that we do, we almost always use multiple agents or platforms, whether it's Mythic, whether it's Cobalt Strike, whether it's something like custom and in-house. And ideally, if I'm listing a directory on one platform, I don't want to have to list that on every other C2 platform as well, right? If you already have that data one time, it should be unified in that unified view, but nothing currently does this, right? Everything's siloed, whether it's Metasploit, Cobalt Strike, Brute would tell, whatever else, Stage 1, all these different types of things. Everything is its own little silo of info.
And another challenge, extremely difficult, is tool output triage. So just doing file share triaging on a host. File share triage, it takes the most time. You're looking through all these individual files. You finally get an agent. You're looking through files on this system. It's like a 70, 80, 90% success rate of finding important information on a host that's on this network, or maybe passwords in a docx or PDF or something like that. And it's just annoying. It's tedious. It's inconsistent. Especially for hosts that if you log on to a IT infrastructure engineer's machine and you can look at all of the hosts that are on the system, maybe that's not actually useful for you until 3 weeks later. You might see that you have something about a host that's super important, but you don't realize it's important until 3 weeks later.
And if you're kind of triaging files, how a lot of teams currently do, right? You're downloading everything, you sync it to your host, and then individual operators are just going through and reading documents and maybe making notes in kind of unified place, a unified note sharing app or something like that. But this is definitely inefficient because there's just a lot of data that ends up either being lost, ends up being overlooked because one person manually can't go through that amount of data usually that gets downloaded. So it's definitely a big problem. It's we view as kind of one of the really big meta problems for red teaming that we've run across.
And it's super successful. We want to be able to do this at scale.
We have to do it every time, but it's very tedious, and there hasn't been a way to automate or augment some of that stuff as of this point. And we're red teamers. We like building tools that help make our lives easier. So that's one of the things that Nemesis kind of aims to do.
Yeah. So one of our long-term goals for Nemesis is to empower analytic capabilities. We want to model things offline on an off-network model. Being able to have these analytics, this data in some sort of our own data warehouse, our own data area. We want to model things that are beyond Active Directory. Bloodhound does a really great job at modeling Active Directory. What if we were able to do this, but for the entire system, the whole host, the whole network. We also have workflow-specific triage functionality and operator assistance. So, we have all these workflows, especially, think like Active Directory Certificate Services, ADCS. Like, there's a very specific, we analyze the templates, we see if we have enrollment rights, and, check for a few parameters, and maybe we can enroll in a certificate. Like, there's a very specific workflow that, we might be able to automate or provide operator assistance.
And this is something where we think there's going to start being an emerging discipline of kind of offensive data analysis. Like, we've been doing this on the defensive side forever, right? People get structured data, they do their analyses, you have your virus tools, your EDRs, you have your Elasticsearch, all those types of things. We want to take some of those lessons from the defensive side and start applying them to offensive data analytics as well. So workflows that's not necessarily the sexiest thing, right, when you just kind of describe it like that, but it's trying to think about how operators actually digest information and get to the next step in an engagement, and what are things that we can do to help facilitate that.
Another one of our long-term goals is to enhance knowledge sharing, coordination, and reporting. So this will be something like suggesting actions or some sort of analytic technique for operators. So you can kind of think of this like an evil Clippy that it talks to you and says, hey, I see you're trying to like escalate privileges. Have you tried gathering this type of data? Have you tried analyzing the registry this way? So that's kind of how we think about it, like an evil Clippy.
So imagine one kind of canonical example I like giving, or we like giving, is say you download some kind of AWS or like Azure-based token from a host, right? You download it, and we ideally would want a system that would detect what that type of file is, or if that token is valid, what the service is for, if it's still usable, and then ideally actually link to say like, hey, here's our playbook for other additional tools that you can actually abuse this type of thing. So this idea of contextualizing tradecraft with data from the op itself is something we're trying to move towards. We're not quite there yet with the Nemesis stuff, but we're building the platform that will allow us to do this. Contextualizing all of those, all your runbooks, all these different types of things, all that kind of all the knowledge that your team actually builds up, contextualizing it with data from an engagement is a way you can actually scale this tradecraft, in a pretty automated type way. And then additionally, be able to track the progression of an engagement, and just all that kind of reporting, all these different types of things, of not just these are the hosts we touch, not just for deconfliction and things like that, but saying, you think about code coverage, but for an offensive engagement, right? Did you check all these particular types of things? Instead of just having a checklist or, people are like clicking through and trying to run through with that, actually having an automated system that can track the progress of an engagement over time. Because ideally, we want to be able to use this data to actually gain insights into operators' decision-making processes, and then in the future, try to use that as a feedback loop to try to improve some of these workflows and things along those lines. And one of the other big long-term goals is we want to enable research. So we've tested, hundreds and hundreds and hundreds of different networks, but all this data and these lessons and all of these types of things eventually get lost, right? Because they're in these, most of the output tends to be in this unstructured text-based output from different tools as things kind of come in. But if we had all of that structured in a place that we could actually run analytics, run analysis, and actually find trends in a lot of the data, we could derive a lot of future kind of ideas for where we might want to perform research, whether it's particular vulnerability research and different drivers or binaries or things that get pulled down, potential new attack paths that might emerge in the host, either for escalation or for even Active Directory attack paths and things like that. We just don't have the ability to get the data in a form that we can currently to do that type of analysis, right? So this is part of the reason that we wanted to build this structured data enrichment type thing that we're going to go into a lot of detail on, so we could actually start building offensive data sets to do future research, to do statistical modeling, any opportunities for machine learning and things like that on this type of stuff. So, the vision for Nemesis, kind of the elevator pitch. I've been talking to a lot of people in the hallway about this. But the one way to frame it is it's a centralized data processing platform that ingests, enriches, and performs analytics on offensive security assessment data. Another way to kind of look at it is it's almost like, in one way, it's kind of like VirusTotal for offensive engagements. You submit a binary to VirusTotal, it does all its different analyses and all the different engines and things like that. It breaks stuff down, does Yara signatures and all that. Imagine that same set of repeatable, automated, enrichment actions, but with an offensive focus. Someone else I was talking to was like, oh, this is almost kind of like an intelligence platform for red team operations is kind of what we're building. And one other way you can kind of think about it is, like I mentioned before, we've been collecting this type of structured data on the blue team side so we can understand adversaries and environments. We've been doing this for years, right? We want to take that same idea of collect all the data from a host during a red team engagement and use that to help guide operators going forward. So that's a couple of different ways of looking at it. I know some people still might be asking, okay, what the heck actually is this thing? So we have a nice diagram. And before anyone groans, yes, it is Kubernetes. There is a reason that we use Kubernetes, which I already hear some people snickering. But the main reason we chose Kubernetes as the core infrastructure is we wanted something that could run locally on an individual host, but also something that can scale to lots of engagements. So you could run one instance of Nemesis for each engagement that you're doing, or you can run one instance of Nemesis and have every C2 from every engagement actually feeding into the platform. So starting on the left, we have connections or connectors for different C2 platforms that Max is going to talk about in a few slides. We have things for OST Stage 1. We have connectors for Cobalt Strike, which is one of the main C2 platforms we tend to use. We have stuff for Mythic, a connector for Mythic, which is another C2 platform that it's like a C2 front end. If people aren't familiar with it, the different agents can utilize. We develop it in-house. It's all open source as well. We have a connector for Metasploit, all that kind of fun stuff. So as data comes in from our different C2 agents, The connectors will take this data and post it to a web API endpoint, the Nemesis web API. This is how the data gets stuffed in and starts in this enrichment pipeline. For example, as you download a file through Cobalt Strike, you don't have to do anything. It'll just automatically shove the file to Nemesis for enrichment, and we'll show this in some of the demos. For file processing itself, data is either stored in S3, encrypted, KMS, all that kind of fun stuff, or MinIO, which is kind of like locally S3 compatible storage in the Kubernetes cluster itself. Then the enrichment pipeline starts to kick off. We use RabbitMQ for a queuing system in the back end. So as data comes in, you have different message types, and we have little microservices and containers that will do enrichments, which we'll go into details here in a second. After that, so some of the example enrichments for anything that can have plain text extracted from it. So for any Office document type, we use Apache Tika to extract all the plain text. This eventually gets like indexed and analyzed and all this kind of stuff. So we have the ability to basically have a text-based search engine, also a semantic-based search engine for every document you download on an engagement. It's just one type of thing it does. We use Gutenberg to convert any Office document to a PDF that can be rendered right in the browser, so you don't have to download all these files, you know, all your open offices and all these different types of things, and like open up in a bunch of different programs. You can just browse to the file details, and it just lets you actually just visualize that PDF, you know, for whatever converted format it is. We also have things like canary detection. We convert everything in PDFs in a non-networked container. It doesn't have access to the internet, so canaries aren't going to call out for at least Office documents. We have some basic ML stuff with TensorFlow, so it tries to detect if any of the text looks like a password. We do different types of regex checking for different known text-based patterns using something called Nosy Parker, which is like a regex engine with an offensive focus. We have NL, natural language processing stuff for semantic search, which I'll talk about in a bit. We have a whole container for like .NET processing, lots of different little things, right? Anything that you would want to repeatedly do every time to a type of file that comes in, you can build a microservice for it, and that will happen every single time you ever download that type of file. After these enrichments happen, the data is stored in a semi-structured form in Elastic with Kibana instance, so you can do any of your flexible searching with that. And it's also stored in a highly structured form in Postgres. And I'll get into some details here in a second. But data comes in, goes through a bunch of enrichments, gets put in different forms in the end for you to consume. And we try to do our best and properly build this to where we have FluentD for logging, Prometheus for metrics, Grafana. We also have Slack alerting, so if certain interesting things happen in files or data, you actually get alerts up into Slack. I forgot to mention we have a password cracking container, so if hashes are extracted automatically, it'll try like 20,000 common passwords and then like alert you if it gets cracked. All these different fun different things. This is the core infrastructure, lots of different moving pieces, but as an operator, you don't have to know how these pieces work. You just have your connector connected up. You have a dashboard that we're going to show. Data gets stuffed in, all the magic happens, and you see the rendered information in the dashboard in the end.
Yeah, and you know, just one thing to note is, you know, the password cracker is a pretty simple service. You know, the whole point of this is we have a ton of different microservices that we, you know, are trying to enable you to write your own. So you can imagine a more powerful password cracking container here, where you know, you have your own custom password cracking infrastructure. Any hash that comes in, you can you know, write your own microservice to send to your own custom infrastructure. So this is all kind of plug and play. If you want to, you know, you have workflows that you want to add, hopefully this microservice structure gives you the ability to perform that.
Yeah, and we have lots of examples. We have a good amount of documentation. Right now, Nemesis is in, we're calling it like an alpha state. We're finishing up some of the back-end modeling stuff. We're going to have a 1.0 release before the end of the year, but it's definitely a lot of moving pieces, so it's been interesting to actually build. And part of the reason we have all the FluentD logging and all this kind of stuff is debugging something of this scale and complexity isn't always the easiest thing. We've been developing this for a while, so to ensure that we didn't go crazy, we tried to build in a lot of things that help you troubleshoot as much as you can. So, an example enrichment flow. Let's say you download a file that ends up being a .NET assembly. Nemesis will first detect that it is a .NET assembly. Then it'll go through a number of specific .NET or .NET specific enrichments. For example, it's going to pull any standard metadata out of the file, version info, imports, type refs, signatures, any of that kind of stuff. And again, this will be put into Elastic, so you can search across all binaries or all assemblies that you've had downloaded for the entire engagement. And one of the really cool things is a common vulnerability or class of vulnerabilities that we tend to find on engagements are deserialization attacks for .NET assemblies. So for anyone it's like the binary formatter and all these different types of things, it's kind of a quick, easy win for a lot of specifically in-house developed .NET apps. They tend to have these code execution vulnerabilities that you can use for privesc or lateral movement or whatever else. So we have code that will check every single .NET assembly for any of these common deserialization vulns. And that will be alerted to you in Slack. It'll show up in the dashboard, and it's searchable across everything. We also have the ability to check for command injection, just kind of that, it's not every single vuln that's possibly going to happen in a .NET assembly, but it's the level 1 stuff that we tend to do every single time that we check an actual .NET file. We also decompile all .NET assemblies to source code, zip it up, and we'll actually show this in one of the demos. So again, this isn't magic. This is stuff that we all know how to do, but having it automated that within 10 seconds of you downloading a .NET assembly, having all of this done and alerted to you is definitely going to save you a lot of time. Then after all those specific enrichments happen, again, everything is going to be stored into Postgres and Elastic. And then you can search the Elastic stuff through Kibana, and you can interact with the structured data through the dashboard. Some other example enrichments we have, besides just the file processing, we have a huge amount of stuff surrounding DP-API, the data protection API for Windows. We'll show some forwards and backwards decryption with that here in one of the demos. We have things like a process and a service categorizer, which their tools are, there are plugins for things like Cobalt Strike and Metasploit that will highlight like, oh, this is AV or this is a remote access or whatever else. This will do it for any process data coming in from any C2. It's universal across everything. Because the Nemesis isn't aware of a specific C2 platform. All the data is just shoved into the front-end API, and it doesn't necessarily care exactly where it came from. But also one of the things I forgot to mention, for anyone that actually cares about this data provenance type stuff, every single piece of data that's ingested in is tagged with the time it was ingested, the operator who is actually running the C2, an identifier for the agent itself, and an expiration date. So we actually have a backend service that runs several times a day and checks if any of the data is past its expiration date, it gets expunged. So for us, being professionals, or the way we structure a lot of our contracts, we have certain retention windows for different types of data for engagements, so you can set that and not have to worry about data retention. We also have like a Yara API that Cobalt Strike or Mythic or whatever can plug into and actually run a common set of Yara rules across any file before it's uploaded or actually run on the host. We have a whole bunch of stuff around Chromium cookies and logins. We'll show that in some of the demos. So lots of fun stuff. And this is just an example of some of the enriched files. The text is a little bit small, but you have your like assembly info, company names, file descriptors, file versions, and all that, again, for every single assembly that's ever run through this. You have all your standard hashes for everything. You have magic types already extracted. You have, if it's plain text, if it's binary, if it's Office, it'll have like links to PDFs if it gets converted to PDFs and all that kind of fun stuff. And here, all the way on the right, are some of the example deserialization results, to where if there are actually vulnerable gadget calls within the .NET assembly itself, that gets this is what we mean by the unstructured data. This is essentially a JSON dump of what shows up in Elasticsearch. Now,
all right.
Collection.
So we're going to talk about, we kind of talked about Nemesis itself. We're now going to talk about kind of the data collection, so before it hits Nemesis, and then the analytics that Nemesis is actually performing in just a second. So here are some of the challenges we face with data collection. Number one is this kind of batched versus incremental ingestion. So we're pulling data from a lot of different sources. I guess first to explain, there's an idea of like batch collection. So this would be, think about how Bloodhound works. Technically it kind of does incremental ingestion, but normally when you use it, you collect all of the data up front. It gives you the zip file, and then you plug that zip file into Bloodhound, and it parses all the data. It's one batch. It's a single batch of data that we process and analyze. In Nemesis, it's a bit different. We do this thing called incremental ingestion. So we want to perform these analytics in real time while we're operating. So we can collect data from C2 right as it gets emitted and perform analysis on it. It presents a really significant issue because we never know when our data set is complete. There might be a situation, so like abstractions are built from multiple sources. The Windows services, if you're not aware, are derived from registry keys. It's like current control set services. Maybe the operator just performed a query for all services that start with the letter W. That's not representative of all services running on the system. That's some subset of sources. So we don't know when that data is complete or not. We can also, we can get data from different sources. So maybe we perform a registry query for those services, or maybe we use something like the WinSVC Win32 API library to grab the services from the service control manager itself. Maybe we can also just perform like a registry hive, grab the registry hive itself, upload that. So there's a number of ways we can collect, a single view like sources or like services. And we have to be able to incrementally ingest that data, not know it's complete. So that provides a bit of a challenge. We also have this problem in the current collection methodology that we typically do of information compression. So historically, offensive tools do a lot of data compression. If you think about the tool PowerUp, PowerUp's extremely powerful. It gives you the ability to find privilege escalation on your system. Under the hood, what it's doing for something like service abuse is it's navigating through those registry keys, those service registry keys, and then only selecting and returning services that are vulnerable. There's information compression happening. There's these services are being queried, but never returned to the user. They're just seeing a small subset, the services that are defined as vulnerable. But we may want to go back and look and see what services are actually running. That tool performed that analysis, but didn't return all of the results it had for services.
And this definitely can come into play when if you discover a new attack path, whether it's on a host for a privask or whether it's in a network or whatever else, if your tool had done all the analysis previously on host itself instead of returning the raw data, you don't have the ability to retroactively do that new analysis on the same raw data. So it's compressing all that stuff down and only returning the results that it deems interesting to you, usually in plain text, not in a structured format, and we don't have the ability to retroactively do this type of stuff.
Yeah, exactly. And we do want this data for research. We may be interested in it during the assessment. So it's just kind of a different way to think about data collection on an assessment. It's we want to return raw data and then process it in the back end instead of processing it on the host. So how do you get data into Nemesis? Our goal with collection, integrating tools, is to obtain information from all tooling in the assessment because we eventually want to provide one unified view of how this data looks. It's super simple to integrate with Nemesis. There's 2 post requests that you have to make. One post request is for importing or submitting structured data. The other one is for submitting files. So if you have a tool and you want to integrate it into Nemesis, you have to write 1, maybe 2 post requests. Ingested data is well structured. So this includes, we have types for things like file listings, file data, process listings, services, all these kind of things. So if you have a tool that collects some data like this, you just have to use our format. We have a custom format, and fix your data to this format, and then make this post request, and you're integrated into Nemesis. Your tooling is compatible. We have connectors built for various capabilities. We have a Cobalt Strike, Mythic, Metasploit, OST Stage 1, and Sliver built out already for you. But of course, if you have your own tooling that you'd like to integrate, feel free. Please make merge requests to our project. We would love that.
We also have a Chrome plugin that we're going to talk about in one of the demos.
Yep. Okay, and now we go from collection to analysis. Our goal here, after we perform our data collection, we want to analyze it automatically. Our first goal, what we're trying to do is automate away this level 1 analysis, kind of the boring stuff like we talked about. We're starting with file share triage and trying to, that's extremely boring, it's extremely tedious. We want to automate away as much of that as possible. This approach permits analyzing relationships between different data sources. So, like I mentioned, maybe we can query services through either the service control manager or registry keys or something like that. We have a number of different data sources that we're unifying all into one centralized location to accomplish things that used to, we have to manually analyze.
Yeah, so one of the goals that we're trying to get to by the 1.0 release is recreating all the analysis that PowerUp does, but doing it offline on raw data. So instead of having to run your offensive tool and your offensive code on the host itself, you just need to pull that raw data down. And ideally, you should be able to do any of that type of privilege escalation analysis offline, right? You don't have to do all that stuff running offensive PowerShell or C# or anything else on the host itself.
Yeah, and we want to be able to provide feedback to operators, and suggestions. So either, I talked about evil Clippy. You can kind of think of part of this project as like evil Clippy. That would be something like suggestions, giving operators suggestions, or being able to retroactively analyze an operator's tradecraft and say something like, this operator did really well here and did poorly here. We've collected this data and we can see that they've, they were very stealthy, or they used interesting new tradecraft, or they did something that maybe they shouldn't have, or something like that. So once we collect this data and we analyze it, it gives us a lot of opportunity.
Now, some of the actual cool stuff, like on the ground, like some of the cool, neat things that it actually does from the enrichment standpoint.
Yeah. So here's some of the automations we currently have. This is not an exhaustive list. This is, this isn't the only things that it can perform, but these are some of the ones that we have written currently. So we'll show demos for a lot of these, but we've talked already about the .NET assembly decompilation and finding vulnerabilities, automated vulnerability scanner. We have things like files being scanned for DPAPI and blobs being carved, and then having that forward and backwards decryption. Some things that we don't show yet are archives that are extracted. So if you have a zip file, archives will be extracted, and then all the contents reprocessed. So you download a zip file. You don't have to manually unzip that and then submit each individual file to Nemesis for analysis. It'll automatically unarchive it and then reprocess it, submit it back into that RabbitMQ queue, and reprocess that data. So these are just a few of them, and we have demos for most of the ones listed here.
So how people actually interact with Nemesis, most of the time, it's just going to be through the dashboard that we're going to show. This is still kind of version 1 of the dashboard. It's built on a backend called Streamlit. It's not the most performative thing, but we wanted to start building out some of these workflow assistance type things that we keep talking about. So this is a place to kind of view, triage, and perform analysis of this data in the target environment. This is just showing the number of different process files in this documents, cookies, logins, and all that. So we'll go through these bit by bit. We also have, this is just an example of some of the more details of what gets surfaced to a user when a file, like an Office document, is downloaded. It gets auto-converted to PDF. It's displayed at the bottom. We have, the path that it came from, the machine it came from, timestamps, size, SHA-1s, all that kind of fun stuff. Also, if you see these little thumbs up, thumbs down, question mark, triage parts in that top right, so this will take feedback from people on whether a file is interesting, not interesting, or kind of undetermined, and it saves this, right? So we're actually able to start building labeled data sets to eventually do statistical or machine learning type of processing these types of things. We're getting our operators to actually label data itself. And if multiple people are working in the interface, like all this is synced for everybody. Same with like comments on files, so someone can say, wasn't interesting or had this credential or whatever else. So again, nothing super, super crazy, but it does. We've been using this on a handful of engagements so far, and it's greatly helped speed up the triage of files on hosts. So actually showing, we got 5 demos. They're all about 1 to 2 minutes. So this first one is going to show the .NET assembly stuff that we keep talking about. So this is Cobalt Strike. We have the connector already hooked up. We're going to download our assembly.exe, and it's going to say here, pause, that okay, the file is automatically uploaded to Nemesis. I know the text is a little small. And then we actually get feedback from Nemesis back saying, oh, this has deserialization, here's a link to the file in the dashboard. So this gives us just basic information of SHA-1, magic, file magic type for what the file actually is, and then there's a handful of things that get alerted on, whether it's DPAPI, deserialization, things like that. Then we're going to swap over and actually go to the Nemesis interface. And this all happens within just a couple of seconds. The file is already processed through the entire pipeline. We're going to go to the file triage view. So we see that assembly, we see that nice little deserialization tag with these little icons here. We can download the file, we can view the raw information, we can download the extracted source, which we're going to show here. So again, stuff you could do yourself, it just is done for you every single time. And we see here, this is just an example toy. This is a toy example of an assembly with a vulnerable deserialization kind of issue. It has a binary formatter for the file stream that gets read in. So that got alerted on. You already get the source. Everything gets pulled down without having to manually throw it into deinspy or something like that. Then a little bit more, some of the detailed file information. It'll show some of the same stuff in the cars, but this lets us actually do that triage stuff. And this is the raw Elasticsearch dump to where we see all that metadata information and the imports and all that type of stuff that you can start doing searches across all files in the engagement for. Also with this, anything that gets tagged, so it says deserialization, this optionally gets shot back out to a Slack webhook if you want as well. So we have a different like webhook or channel set up for every engagement we're on, and we start getting alerts coming in as interesting things start to pop up. That's the first demo. Now, Chrome extension.
Yeah, so this is the Chrome extension. It's, yeah, you can see it here. Basically what it does is take downloaded files and then automatically submit them to Nemesis. This is especially useful if you're proxying in a browser. You have an agent on a system, you proxy in a browser, and then anything you download maybe from like an internal Google Drive or SharePoint or just any sort of web-based file server, it'll automatically grab the data and submit it to Nemesis. This is the configuration. This is the agent ID for tracking purposes. And then you pretty much just set it up with the Nemesis URL, the username, and password. We have password authentication for this. Submit it. Configuration is saved. Now we can go and download a doc file, a .doc file. You can see Nemesis will automatically upload it for you to, or this plugin will upload it to Nemesis for you, and then is immediately processed by the Nemesis engine. We can see we now have one processed file. When we look at it, we can see we have the doc. We're able to re-download the file. For other operators, if they want to look at it, you can view the file as raw. So this is more useful when you don't have a doc file. You can look at it as a PDF. So this is extremely useful. Instead of having to download Office every single time, if you just want to see a file, maybe there's this is a watering hole attack or whatever, it'll automatically process it into a PDF that you have the ability to view extremely easily. We can also check the detailed views, the detailed view of this. You can see it'll extract as plain text. And yeah, give you just the detailed file view. There's also a document search built in, so because we extract the plain text out of document files, we can do just arbitrary searches for all the files that we've downloaded. So we look for passwords, and we can see that this document has a password string in it.
So this is definitely useful if you're going after like Project X or information about System Y or something like that, right? As you're downloading these huge swaths of things, you basically get a Google-style search engine for every single Office document that you've downloaded. And again, any file that can have plain text extracted from it gets indexed. Same with, we have a separate view for just source code, and then for the semantic search, we actually use a small language model. It's an SBERT model to do sentence embeddings, and we chunk everything up and actually do semantic vectorized type search, a little bit of natural language processing stuff as well.
Yeah, if there are multiple files, it would show 1, 2, 3, 4, 5.
Yeah, it's paginated. It's like any arbitrary number. So the question was, if there are multiple files, multiple hits, yes, it'll do like an arbitrary number, and you can like go page by page. And this is, again, this is just straight text search. But then it'll, if you click like the path, it'll link you to that detailed file view that shows you the host it came from, then when it got downloaded, and all that kind of fun stuff. Okay, let's see. Next one is Nosy Parker and hash cracking. So we're back in our Cobalt Strike interface. We're going to download a couple of files. One is an encrypted zip. One is a sample config file that has some known token patterns in it. So give it a couple seconds, everything gets processed. We're going to go back to the file triage view. We see in this Google config, it has Nosy Parker results, which means it likely has some kind of password or token or whatever else contained within it. This is all sample data from the Nosy Parker site as well. So we see if it's text, we actually have a Monaco Visual Studio style editor at the bottom. So if anything's like source code, it does syntax highlight and all that kind of fun stuff. But we see we have a tag, and you can, in the file search, you can like filter for all the tags, and you can search any which way in order and all that kind of fun stuff. But we'll actually see, we see the elastic info, we see, all right, there's some of this weird structured Nosy Parker results. We actually have a Nosy Parker view that shows up if there are results, and it shows, oh, this is the rule, Google OAuth access token, that's the matching text, and here's the context for the document. So Nosy Parker is an awesome tool. It has tons of different offensive-focused regex like rules built for it for any number of different things. There's like an example OpenAI key. And this, again, will be alerted in Slack as well. So the moment that any interesting passwords, tokens, whatever else gets discovered in any file that you download, it'll all just automatically alert you, and you can hop back in here. This is an encrypted zip example. It tells you it's encrypted. We support about like 20 different encrypted files. We're expanding this, every couple of weeks we add some more. But if it's like an encrypted doc, encrypted zip, encrypted whatever else, we use like doc to John or whatever else, the hash extracting tools from John the Ripper, extract out a hash that the hash for that file that can be cracked to John the Ripper. It gets auto-ingested back into Nemesis, and then we try 20,000 most common passwords against it. And that, again, you could build like Max had mentioned, you could build a different service that takes that and like shoves it into a password cracking queue in the cloud or something like that. So we see our hashes. It was extracted, auto-cracked. We would have gotten an alert in Slack saying that password was actually cracked. Password 123, bang. So again, nothing super crazy that you couldn't do kind of yourself, but it's just happening for every single time without you having to do anything manually. All right, now one of my favorite ones is Chrome DPAPI stuff. So for people that aren't familiar with DPAPI, the data protection API is the supported way to store data encrypted at rest on Windows systems. I don't have time to explain the entire system, but the TLDR is you'll have information that's protected by keys called master keys. These master keys are protected by a user's password and also a backup key that exists on the domain controller. So here the example is we're going to download the login data file for a Chrome instance. This is where your saved Chrome passwords are stored. We download that. Then we're going to go up one level, and we're actually going to get the local state file. So the login data is protected with a key that's stored in the local state file. That local state file, that key is protected with master keys, and the master keys are protected with domain DPAPI backup keys. So if we download the local state, we download the login file, and we download all the user master keys, we can't actually decrypt those Chrome logins yet because these master keys are still locked up. But we're going to show in the interface that everything was detected, everything is linked, so all these are linked together. So if we show the Chromium view, we're going to go to the logins, and currently they're all encrypted. So we're actually going to click the little slider that says show the encrypted logins. We see, okay, it is not decrypted yet. Now, if I have DA in this example, I'm going to run sharp DPAPI to extract the domain DPAPI backup key from the domain controller. This text through the Cobalt Strike plugin is going to be recognized as a domain DPAPI backup key. It's going to be auto-ingested into Nemesis, and then that backup key will retroactively decrypt any master keys. Those master keys will retroactively decrypt any local state files, and that will retroactively decrypt any logins. So we have forward and backward. If we download new Chrome logins or cookie files from the same user, those will automatically be decrypted. But because all these pieces are linked, the moment that you have all the puzzle pieces, everything will just be ripped apart. So, last bit, show I'm not lying. Lots of stuff going on in the background, right? But it all gets like retroactively decrypted, and we see we have our decrypted Chrome login. And this works for cookie values as well. We can just actually show in the DP API view for master keys that we have all these particular master key files, shows they're decrypted, and shows that this one has a linked like state file. Same with any other DP API blobs that get auto-carved from files as well. All right, and last demo.
All right, and then here is the collector. It's a BOF. If you're familiar with beacon object files, this is written as a BOF. It collects registry keys from the system and then submits it to Nemesis for analysis. So pretty simple to use. We can use BOF reg collect, specify the hive, and then the target path we want to collect from. We're collecting from current control set services. I've mentioned this path before. This is where this is the services database for services on Windows.
And again, we're just collecting the raw registry values here.
Yep. So it uploads this file, BOF reg collect Nemesis. This gets uploaded to Nemesis. And then now we're showing off the Postgres. We're showing off Postgres. So we talked about, this stuff gets added to Elasticsearch. It also gets structured in a more, structured format besides, just raw, Elasticsearch, and gets put into a database. So what we can do here is select all the keys from the registry table. When this gets parsed, you can see that all of the registry keys are here. So now we can perform SQL queries against all of the data that we've collected. What's also cool is that once these registry keys are added, they're reprocessed by the Nemesis engine. They're resubmitted into that queue for further analysis. And so one of those, the kind of abstraction we have here, is the services abstraction. So those registry keys, we can tell the key path. It's HKLM and then current control set services. We know that these are now services. We can then insert them into the services table. And when we perform this query, we can see that these get added as services. Highly structured, gives us the exact description, display name, command line parameters for how that service is going to get started. All of this data was in the registry. We can either query it by registry keys or this more abstract form of a service.
And then the next step, like we said, that we're currently working on is doing analysis of saying, is this service vulnerable or not for the purposes of privilege escalation?
Yeah, so all of the unquoted service, everything that PowerUp implements, we're going to implement also in Nemesis. I think that's it.
Yep. All right, so that's it for the demos. We have just a couple more slides, and we'll take a few questions. So why this matters, or why we think this matters. So enrichment and analytic pipelines are not a new idea. People have been doing this on the defensive side for a long time. We'll say no one has publicly done this for offensive security. We're big fans of the phrase, if you can imagine it, it's probably already been done. It would surprise me greatly if these types of things weren't done by private groups or governments or these types of large-scale analytic pipelines. But for us, it's not just what Nemesis does with file processing and triage that's neat, but it's what it's going to allow us to do with things like operator guidance, with building these labeled data sets and all. We're really excited for future work over the next year or so of having this nice, cleanly labeled, structured data store of offensive data is going to let us do. And this is also a bit of a potential paradigm shift for red teams, where instead of running your offensive code on host, if you just want to pull raw data offline and process it in an engine like this, this offers you a number of different advantages. So we can centrally update operator analysis workflows. So we have one workflow for every piece of data that comes in, no matter who's actually downloading it. Also, enrichments and analytics that are added exist in perpetuity for all operators and all engagements. When we were beta testing this several months ago, we just had the deserialization check for .NET assemblies. When we were on the engagement, we actually found like kind of a command execution, JavaScript execution type bug in manually when we were analyzing an assembly. Axe modified our analysis code to check for that same type of thing. And now every single assembly we ever download forever is going to have that same check. So it's definitely kind of a force multiplier. Offline processing allows for that retroactive analysis like we kind of talked about, where if we come up with a new thing that we want to check that we could derive from that raw data, we can reprocess all of our existing data and have all those new analytics. Again, this minimizes the footprint for offensive tooling on an endpoint. You can have a very dumb agent that just has the ability to download files or pull raw data, and then you can throw it into this. And like we mentioned before, that collected kind of structured and unstructured data will hopefully help guide us for future research. So thank you. I think we're just about on time. We're just about at 51 minutes. So if there's any questions, we have 2 giveaways. We have a lockpicking kit, and we also have a practical deep learning book. So, okay, question.
Yeah, so this looks great that we can pull all of our information.
Mm-hmm.
Do you foresee a point where you're pushing that information back to the tools? So, right, I've got global strike and dump hashes. I want to push it to Method or some other C2. Do you see that being?
Yep. The question being, we have data that can be ingested in. Have we thought about pushing data out? That is absolutely something we're interested in. We just had a bunch of conversations last week with some of our internal teams about doing that. We definitely want to build that in, especially with, as you're triaging files, even as a basic example. This is interesting or not. Having that data fed back into the file view in Mythic or something like that. We also have ideas of if we're facilitating like doing statistical modeling for things or file share mining and all this, we absolutely want to have that operator assistance fed back into C2 tools. We just don't have it built out yet, but that is absolutely going to be on the roadmap. So would you like lockpicks or deep learning? All right. I would have picked the deep learning book, but I'm a nerd, so. All right, any other questions?
Yeah, we got one up here.
Oh.
So you said after the engagement expires, you're going to purge all the data, you're going to throw it. Is there going to be, or at least talks of an option where you can anonymize or some type of way of removing the customer information from that data so that way you can keep it and still do the statistical learning you're talking about?
Yeah, so the question being, so the way the purging currently works is you don't have to put an expiration time in, right? So you can just, it's not going to remove data unless you tell it to. So by default, when data is ingested, you can give it a number of days until the data is purged. So you can just set that as -1 or 1,000,000 or whatever else. The reason we did that is because of, contractually, we have to purge things after a certain period of time. This isn't an issue for, say, government teams or internal teams. Like, different people have different data retention kind of policies and issues. As far as anonymization of the data, we've had lots of meetings and talks about this. It's harder than you would potentially think to do it completely correctly. Even something as simple as a file path could have a username, it could have the domain name with the username, and the dot context, it could have a project name, it could have something sensitive in the file itself, and it's difficult to come up with a way that you can guarantee that things are going to be anonymized, but it's something that we're definitely exploring, and each piece of structured data is going to be a bit different in how you would actually approach that anonymization. So we have the ability to collect, you could use Nemesis for every engagement you have and have it all in one central store. And if you don't have to purge your data, you could do really cool analytics across all your different engagements, right? All that type of stuff. That would be my pipe dream, but contractually and ethically, we can't do that for our particular engagements. But that's something we're hoping to explore in the next few months with also some other teams that we've talked to of what's a good approach that we can start anonymizing and scrubbing some of this stuff. So, would you like a book? All right. Any other questions?
Yeah, go ahead.
With respect to your purging, do you also track the provenance that you can purge to derive artifacts?
Oh, yeah, for files.
Yeah, I think the timestamp is imprinted on further data, I believe. So if you have derived data.
Oh, derived data. Yeah, it's the timestamp gets filtered down. So as we build a service abstraction based on registry data, that gets, we are guaranteed, the way we have our schema set up for Postgres is you are required to have that expiration time and original timestamp for every single row of every single table. So it's built fundamentally into the schema because that's something it was a core problem that we thought about from the beginning.
So a couple things. One of the challenges you're talking about purging is if you're dumping data into Elastic, that's immutable, so you can't really change it, right?
Yeah, currently, that's a good point. So currently the way we currently use Nemesis is we stand up one instance per engagement and we tear it down with the rest of our info to like guarantee. We purge everything from Postgres. I forget, we were working on purging stuff from Elastic. I don't know if it's completely there yet or not, because I know it's immutable, but I think you can still remove the individual documents after they get stuffed in, but I don't think we've completely solved that part yet. Yeah.
Cool. Any other questions? What's up?
Those kind of like two questions, but do you have any way of doing like tracking those changes so that you can run a service query on a host, and later that you can run another service query when you alert on it?
That is something so Lee, who is not here, is, he's working, so the hardest part of that problem is the representation of a host when you're pulling in C2 data from lots of different things, because how can you, if you have, some tools will report like a domain or a host short name or NetBIOS name, some have a fully qualified name, some have an IP. So we spent a lot of time trying to figure out how we can actually model that across lots of different C2s. So we have to solve the host-based abstraction problem first, which we're pretty sure we have a solution for. It's being coded right now. And Lee had also, we've started to address the temporal issue, or like a process listing is the great canonical one, right? We intend to support that. The code is not there yet, but it should be for the 1.0 release.
Sort of branching off of this, what about like custom alerts? So say you grab URLs from Chrome, and alert like if the URL were an internal domain or something.
So we have like an alert message type that you could build an additional microservice, and like it's literally submit like a RabbitMQ message of type alert, and then it'll filter up to whatever your alerting mechanism is. We're also working on, we want to get Jupyter notebooks in, like long-running Jupyter notebooks with a bunch of supporting packages and stuff, so you could run like, okay, anytime plain text comes in, let me check for this term or something like that. So it's something we absolutely intend on supporting.
We got 3 minutes.
All right.
Any other questions?
One more. Yep. Yep. Yeah, absolutely.
Oh, yeah.
We have documentation for it. That's why we tried to do 5 or 6 different plugins to show, because literally all it is your code just needs to take the info from the C2, whether it's a file download, process listing, or whatever, and then it just makes a post request with that data to the Nemesis endpoint. That's it. So it can be completely self-contained. Like the Nemesis connector is a small Docker container that just runs completely separate from Nemesis and then posts stuff into the API. So that's 100% a thing we wanted to support for everybody. We have documentation on building your own connector and like 5 or 6 examples. So cool.
Awesome. If you have any other questions, please find us around the con.
Yep.
We'll be here.
Yep.
So.
We have a SpectreOps booth out there that we'll be hanging out at if you want to come ask some more questions. But thank you, everybody. Thanks for listening to us talk about data for a good hour. So.